Thank you so much. This event is awesome. I'm really excited to be here. And I've loved the conversation so far, and I think this is going to build really nicely on what we've been talking about. And so I think you're going to like the content. I will say it's really hard to follow Steve just in terms of graphic design. I want to know who your slide person is. I'm really jealous. Yes. So I'm an economist, right? And so I'm going to pick up on a lot of the themes that we were talking about around incentives and cost effectiveness. And I'm going to go really quickly through the early stuff, which we all know. Cat losses are growing really fast across all kinds of perils. We're talking a lot about wildfire today, but this is relevant for hurricane risk. This is relevant for extreme rainfall. This is relevant for lots of perils. So how do we think about managing all of these risks that are escalating so fast? I think, simple economics, the kind of stuff I teach in my intermediate microeconomics class, gives us just a very nice kind of framework for thinking about what to do here. I would argue that we want to do two things. We want to engage in what I would call physical protection, hardening assets, making things less likely to be destroyed. And we want to do that to the point that those investments pass a cost-benefit test. There are things that we could do that would, we could pave the Western United States. There are things we could do to essentially eliminate the risk of wildfire loss. Some of those things are just not going to pencil out on the margin. And so we want to look around. We want to do the things that are cost effective. And then once we've done those things, that's where we want to turn to insurance markets or other, financial protection programs to make sure that that residual risk, that remaining risk that's always going to be there is managed, and that at least when the worst inevitably happens, those unlucky people have resources available to get their lives back on track. It's obvious, I think, why insurance markets are so important for financial protection. It's actually also, insurance markets can help us a lot with physical protection as well. And the reason is that when we have well-functioning insurance markets, the premiums are going to send ex-ante signals about the value of investing in cost-effective mitigation. Okay, so I would argue that insurance has a lot of potential to help us manage these escalating risks. Of course, if we look around, what we don't see, we don't appear to be living in a world of smoothly functioning, frictionless insurance markets that are gliding us into easily managing a new world of climate risk. That's not the world we're living in right now. We have a bunch of challenges where I would say we need a lot of effort on research, reform, and innovation. And I think, for what it's worth, I think the title of this panel on the agenda is the economics of uninsurability. My take on this is that these perils don't have to be uninsurable. I think there's a lot we can do on the markets and the innovation side to make these things coverable through insurance markets. But what are the problems that we're facing right now? We have correlated catastrophe risk. That's like a classic challenge for private insurance markets because they need to do expensive things to manage their solvency when they know that they could get a lot of claims from a bad event all at the same time. We have lots of reasons that these perils are really hard to price, and that's why we have cat models. And it's really cool to see Karen Clark here, and I'm going to pin you down during the breaks and ask you lots of questions. We have a complicated regulatory framework at the state level across 50 states. We also have a little bit of federal government involvement. And we have just really tough distributional trade-offs at the end of the day, to the extent that we want to design insurance markets to send high-powered price signals about the value of investing in mitigation. That means we're going to have to break down a lot of the cross-subsidization that has happened historically in these markets, and there are going to be a relatively small number of people who live in relatively dangerous places that, if we go that way, are going to face substantial increases in their insurance premiums. And those distributional trade-offs are tough from a fairness perspective, and they're tough from a political perspective. So you put all those things together, where are we right now in terms of these markets? Well, everyone knows this. We've seen skyrocketing insurance premiums in private markets, shrinking availability of private homeowners insurance. Public pools like the National Flood Insurance Program are seeing really large losses. And in general, if you sort of look around the United States and other countries, in a lot of cases, we have prices that are divorced from underlying risk. Okay, so what do we do? I want to use my time to talk about sort of four 4 areas that I have been thinking about in my research recently with co-authors, where I think social science and economics can help us figure out how to make these markets work better. I'm going to talk about driving cost-effective mitigation investment. I'm going to talk about making high-quality information broadly available to all players in the market. I'm going to talk about the importance of managing the cost of correlated risk. And then I'm going to talk about carefully designed policies to handle the distributional challenges that we talked about. Okay, so cost-effective mitigation investment. Steve's presentation was absolutely awesome. I have not much to add on the effectiveness of mitigation beyond all the really smart scientists in the room. I think what I can say a little bit about cost effectiveness, a lot of my research has been thinking about this in the past few years. We know that all of these, there's a ton of low-hanging mitigation fruit out there. And not only are there a bunch of things that work, there's also a bunch of things that would work at low cost. So I have a big paper with my co-author Patrick Bayless. We study over 100 wildfires in the western United States, in California and outside California. And one of the things we find in that paper is that California's work to write mitigation practices into building codes for new homes has just been staggeringly effective in reducing the loss of new homes. And that shouldn't be surprising given everything that Steve told us about how effective these things are. It's a little bit surprising to see that people really aren't doing them in the absence of a law requiring that they happen. And we also show in that paper that those codes are just strikingly cost effective, especially when you consider not only the benefits to the person owning the structure, but the structure-to-structure spread reduction that we talked about. So lots of economic evidence that there's things we can do to lower loss risk. As Steve talked about, existing properties are sort of a tougher nut to crack. It is just true that it's more expensive to do things on a property that's already been built, but there's low-hanging fruit there as well, and there's a lot of really great research happening right now on community-level mitigation and landscape-level mitigation. I'm not going to tell you much about the science of that. That's not my job. My job is to think about cost-effectiveness and behavior and incentives. And so despite the fact that we have all of these great things that we could do on the mitigation front, the sort of first order fact is that historically we just had not had a lot of take up of these self-protective investments, right? Why? There's a variety of reasons around pricing and incentives. One historically really important reason has just been information and attention. People have a lot of things going on in their lives. They're not always thinking about wind risk or fire risk or hail risk. I pulled here one of my favorite graphs. This is not from my work. This is from a really great team at the U.S. Forest Service. This group goes around and they go property to property in individual communities in the U.S. that face a relatively high wildfire hazard, and they do the following thing. They meet with the homeowner. They interview the homeowner and ask them a bunch of questions about what they perceive to be the wildfire risk that their house faces. And then they have the experts on the team do an expert assessment of the kind of best available science. How would we actually classify the risk to the structure? And they make pictures like this that often look really different. So what is this picture telling you? This on the bottom bar there, the household survey, this, and for what it's worth, this is from Santa Fe, New Mexico. When this group surveyed homeowners about how much defensible space they thought they had, what the distance from the walls of the house to the nearest dangerous vegetation was, most people thought they had at least 30 feet of defensible space, right? You've got 35% that think they have more than 100 feet, another 37 that think they have 30 to 100 feet. When they had the experts go through and assess the exact same homes, what did they find? Essentially nobody has more than 30 feet of defensible space. So big, clear evidence that the risk information isn't always getting through and we're not always capturing people's attention. Okay, so what do we do? In our work, we're now trying to think about behavioral interventions and economic interventions that can actually move the needle on property owner engagement and behavior. So one of the things we've been doing in cooperation with the Western Fire Chiefs and the Oregon State Fire Marshal is we've been running randomized control trials in high wildfire hazard communities in Oregon. We've run pilot experiments so far in Medford and Eugene Springfield. We're thinking now about how to scale this work up. And if anybody wants to talk about places we could run more experiments, please talk to me offline. This is an example of the kind of thing we were doing in Medford. So this is just one neighborhood of many neighborhoods in our study. What we did is we randomized homes in this neighborhood in Medford to receive one of a few different treatments from us. Houses in purple, we left alone. We didn't contact them at all. Houses in, kind of blue or dark green got a letter from us that said, managing wildfire is really important. The fire district is here to help you. If you work with the fire district to make some progress on our defensible space metrics, we'll write you a check for $250 or $500. And then the bottom two groups, the information groups and the moral information group, got that same letter, but it didn't say we'd give you money. It just said, hey, wildfire is really important. The fire district is here to help you. And so what we're doing is we're trying in this kind of classic clinical trial design to see what moves behavior, right? And I think everyone already has their prior about what's going to move behavior, but let me show you the pilot results. There's basically no engagement with defensible space resources for the people that we don't contact. The control group's not doing anything. That's not a surprise, given what we know. We get a little kick when we give people information. We get about 3% of them to come into the fire district and start participating in mitigation programs. But we get 3 times that effect. We get about 9% of people when we offer these relatively small financial incentives. So clearly, some early evidence that I'm an economist standing up here telling you that people respond to financial incentives. But it certainly seems like it's true, right? And this is not an insurance pricing experiment, but I think it starts to be indicative of the potential to drive action if we could live in a world where insurance rates actually are able to price this behavior. Okay, that's one thing that we've been working on. Let me jump to the next closely related topic about high quality risk information. And so we've already had great discussion today about risk information. Wildfire in particular is a peril where our scientific understanding of the risk is evolving really fast compared to perils that we understand better, like flood and hurricane and earthquake. So we have lots of models. All the models are developing really quickly. Many of them are proprietary, so it's hard for us on the outside to know what's going on the inside of those models. That's one thing. Lots of different views of the risk to a given structure. Separately, if you just think about trying to understand as an insurer or a home buyer or a community board of, like a county supervisor, you want to understand what is the state of a given structure. What's the roof made out of on a given structure? How much defensible space does a given structure have? There's no easy way to get that information right now beyond sending your own inspector out to do an inspection on the property, which is incredibly time consuming. And we have all kinds of duplicative effort from various players that are trying to gather all that information. So that's another really important information challenge, that even if we have models that can model the risk to a structure, those models are conditional on what the structure is made out of. And we need just like the basic data about these structures to price them well. Those and other information challenges have led to what I think of as sort of a fragmented information playing field, right? So I have this paper, the 2025 paper about the California wildfire insurance market, and we document kind of the striking variation in the information that insurers are using to price risk. We talk about the various unattractive outcomes in insurance markets when you have that kind of disagreement about risk information. And I think more broadly, as Ramesh and other people were talking about, we have property owners, home buyers, regulators, all working off different information about risk, and it sort of gums up various outcomes we'd like to. Gum up is a technical economic term. Okay. So how do we move towards a common view of risk, and can we move towards a common view of risk? What's possible here? Of course, these are like fundamentally ambiguous and uncertain perils. But I think there is progress, just pure scientific progress as we understand these things better. An optimist might think that will shrink uncertainty and lead us to alignment. I think there's also a lot of room for well-designed policy every year. So I'm really excited about what Kara is doing at the department, and it's really fun to hear the update on that. And I think that's a really important part of this. And I also really appreciated Karen's question about uncertainty, right? So I think part of aligning around a sophisticated and common view of risk is being honest with each other about what we can and can't know. And it is very hard to communicate uncertainty to the general public, but it's really important that we find a way to do it. Okay. I want to take, this is going to feel like a little bit of a U-turn or a left turn since we've been talking about wildfire all day. But I want to talk for a minute about hurricane risk in Florida in this context of information. It turns out that Florida has a regulatory commission called the Florida Commission on Hurricane Loss Protection Methodology. It is in spirit, somewhat similar to the effort that Kara has been leading at the California Department of Insurance. It's been around for a long time, like 25 plus years. What this commission does is they oversee catastrophe models that are going to be used to price hurricane insurance in Florida. And so what I want to talk about is a new paper that I've been working on with Patricia Bourne at Florida State and Ben Collier at Wisconsin and Toby Huber at Georgia, just to sort of illustrate the value even to academics, the things that we can learn about these markets when we make information more widely available. Because one of the things that the Commission on Hurricane Loss Protection Methodology does is they require modelers to disclose standardized model outputs on like a comparable home every couple of years. And what we've done is we've pulled together all of that historical CAT model data across a bunch of different models, across a bunch of different Florida zip codes, and we've combined it with data that we've put together on insurance prices. And that's going to let us understand how the insurance industry's view of risk has evolved over time through these CAT models, and how pricing has evolved and how those things sort of play with each other. So we can do kind of obvious things, like we can say, how has modeled risk changed over a 20-ish year period? Across all the models that we can see, there's a general story of a 40-50% increase in expected losses. This, I'm showing you the Verisk Air Worldwide model, which is one of the more widely used models. What is this map? These are Florida zip codes in 2006 and 2023. In every zip code, we're showing you the expected annual hurricane loss on a standardized property. It was built in 1990. It's made of essentially cement block. It's the most common type of property in Florida. And this is what the CAT models tell you about the expected loss for that property. You can see, unsurprisingly, hurricane risk is concentrated on the coast. And over 20 years, that risk has gone up, especially in southern Florida. That's for the Air Worldwide model. This is true about other models as well. I think some of the more interesting stuff that we can do in our paper is we can combine that with the insurance price data. So we've put together insurance premium data that covers 70% of Florida homeowners. We'll talk offline about the statistical process that goes into this, but think about having hurricane premiums for that same standardized structure that was built in 1990 and has the masonry construction, all the things that we were talking about. So now we're going to think about, over a very long time period, how has the CAT model view of risk changed, and how have average insurance prices for that same type of property in Florida changed? And you can see when you put those things up against each other, the red line at the bottom is the CAT model view of risk. That's gone up, and in particular, it's gone up recently in response to a model. It seems like the models really responded to a 2017 hurricane season. Karen will tell me if that's wrong. But you see the growth in premiums has been substantially faster. And I'm going to talk in a minute about why we think that is. We don't think it's that insurance companies are making huge profits. But this is the kind of thing that we can do. We can understand trends in prices, trends in expected losses, and we can try and break down and understand what's going on between 2020 and 2024 when we have a 50% increase in hurricane insurance premiums in Florida, right? That's the research question in the new paper. Come talk to me offline, happy to talk about it. So why, and then the next thing I'm gonna pivot to is, why is that purple line so far above that red line? what explains what we would call the really large loads above expected loss in hurricane insurance pricing. And we think the answer has a lot to do with the high cost of covering correlated accident risk in Florida, and in particular, the special nature of hurricane risk, right? So another thing that we show in this paper is consistent with the picture we were just looking at. On average, the insurance contracts that we're looking at are charging about $5 to cover $1 of expected hurricane losses. So if you're a homeowner, think about your expected losses from hurricanes in a year, multiply that by 5. That's what our data says is going to be the hurricane component of your insurance premium. And furthermore, that's been going up over time in an interesting way that we can talk about offline. And if you look at where those premium dollars are going, a lot of those premium dollars are going to purchase reinsurance.
Can I ask a clarifying question?
Yeah, sure. The hurricane component of the premium. Yeah. Yes. Yes. Yeah. 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 And okay. We'll talk about where the data comes from and how that gets split out, but you should think about that as the hurricane component. Right. So there's a homeowner's policy, of course, is going to cover much of other perils, slip and fall and other stuff. And so there's lots of reasons that your total, I think this is what you're getting at, your total homeowner's premium, of course, is going to reflect a lot of risks other than hurricane. This exercise you should think about is just zeroing in on hurricane specifically. Okay. Why? So what do we think is going on? Basically, it is hard and expensive to manage the solvency challenge that comes from this highly correlated loss risk, right? As an insurer, you face the potential of having to pay a lot of claims at the same time. That basically means you need to go out in the global capital markets, the reinsurance markets, or the cat bond market, and find a way to transfer that tail risk to those capital markets. There are various reasons that seems to be a very frictional and very expensive process. Okay, so we think that's what's going on there, and this all gets amplified a little more in Florida because of the sort of almost perverse structure of the Florida homeowners insurance market, where the most diversified kind of like national and international primary insurers have mostly pulled out of that market, in particular in the highest hurricane hazard parts of the state, and left the market to what we call the Florida domestic insurers, small players that essentially only sell homeowners insurance coverage in Florida. And if you think about diversification, that's like the worst possible place to be to try and manage this tower. So those firms are particularly dependent on reinsurance, and that juices all of these problems even more. Okay, that's probably more detail than you needed on this particular paper, especially given that we're all here to talk about wildfire. But the reason that I wanted to take you through this is I wanted to, one, show the kinds of things that we can start to look at when we have really great risk model data that's made available to the public and to researchers. And two, I want us to be thinking about the extent to which this correlated risk challenge does or doesn't matter in wildfire. From our other work on California wildfire, the loads that we're measuring they're not on the same scale as they are in Florida, but there's more work to be done to understand how important this is in the wildfire context. Okay, I'm almost at time, so I'm just going to wrap up by talking about distributional challenges. This very ugly table is from a short policy paper that I wrote last summer with Meredith Fowley at UC Berkeley for the NBER Environmental Energy Policy and the Economy series. What we do in this paper is we think about the following exercise. We think, what if you moved from a world, and think kind of a rough proxy for the world we used to live in California homeowners insurance, is we basically didn't segment the market at all. That's not literally true, but we kind of pooled everyone together and we charged insurance prices that on average would cover everyone's expected losses across that whole pool. So there was a ton of cross-subsidization happening because that pool included some people that lived in very high hazard places in homes that were extremely vulnerable to wildfire, and it included some people that lived in the middle of San Francisco. And so what we do in this paper is we think about what happens as you move towards more and more finely targeted risk-based pricing. So this is just a purely spatial exercise. What if you segment the state of California more and more finely in a spatial sense into, pricing separately by county, pricing separately by, as Ryan was saying, the risk score metric, the risk score bins that one of the major data providers sells for scoring wildfire risk, or by zip code, or by census block grid, or census block group, or what if you actually divide the state up into like 1 degree by 1 degree lat long cells, which some players in the insurance industry do. And what we do in the paper is we just talk about how the distribution of insurance premiums would change. And there's a wildfire catastrophe model behind this that's telling us the expected losses for every property. And for the nerds in the audience, what we're doing is we're calculating premiums that would equal expected losses in every segment as we cut these segments down more and more thinly, right? Okay, so the total premium being collected across everyone is the same in every one of these rows. It's just how are we splitting it among people? And what you can see, for some reason, to 2 significant digits, I don't know why we did that, is that the people with the lowest risk, the people at the first percentile of risk, as we segment stuff more and more finely, are seeing insurance premiums that are a couple $100 lower than a world where we just pool everyone together. The people on the extreme high end of the risk, the 99th percentile of risk, are seeing massive increases in insurance premiums relative to that world of cross-subsidization. And that just reflects the statistical nature of wildfire risk, that there are a small number of places that are incredibly hazardous. Okay, so really big winners and losers potentially as we move to risk-based pricing. Tough distributional trade-offs. You might particularly care about that, as we show in the paper, because like a lot of other environmental bads, wildfire risk exposure is correlated with income. So if you're lower income, you're more likely to live in a place that has high wildfire risk exposure. Okay, so for political and just fairness and justice reasons, we're going to want to think about how to cushion impacts to economically vulnerable communities as we move towards risk-based pricing that will create good economic incentives to manage risk. It's a hugely important area for research. One thing that I've been thinking about recently is that mitigation subsidies may be particularly attractive here, especially if we can get insurance markets to transmit that mitigation behavior into prices, because then we're giving people money to do something that's going to make their house safer and lower their insurance premium. If you compare that to a counterfactual policy where you, for example, just give people money to pay their insurance premiums, you're not getting the benefits of mitigation. If you compare that to another counterfactual policy where you just don't let insurance companies charge above a certain price, then of course you're threatening the supply of insurance, right? Okay, and then based on the hurricane research, in the places where cat risk is really the cost of managing that tail risk through reinsurance is really driving these costs, there may be things we can do to lower those frictional costs of reinsurance that can lower prices without unduly removing adaptation incentives. And that's why I really want to understand how important what we would call those cat loads or those capital charges are in California wildfire insurance. Okay, so I'm done. I'll just wrap up by saying insurance is really, really important for managing escalating cat risk. We've got all these challenges, but I think there's a lot we can learn from economic and scientific research. Thanks.